For problem 4-45, you were supposed to graph your three equations on an isometric dot tool as well as your 3D graph. If you did this, you would have seen that all three of these graphs, these planes, I should say, intersect at a specific point. However, on a 3D graph, it is hard to find that point. One thing to note is when we have three equations and three variables, you will have the planes share a single point, just like when we had two equations with two variables. So we're going to find an easier way to do this so that we can find this specific point. And that is through using elimination. So for 6-47, it says, looking at the equations in problem 6-45, Alicia wanted to see if she could apply some of her solving techniques from two variable equations in a three variable system. So she noticed that the first two equations could be combined to get 8x plus 7z equaling 18. So that is a process that we called elimination. So we added these together. So 2 plus 6 gives me 8. These would cancel out, 3 and negative 3. And then 3z plus 4z equals 7z. Add up these here, we get 18. So now we have an equation in two variables. However, I need to combine another set of two so that I can get another equation, just x plus z. So I am going to use these two equations because I notice, again, a positive 3 and a negative 3y. So if I add these two, I get 2x plus 2x, which equals 4x. Then I have 3y minus 3y. Those cancel out. And then I have 3z plus 2z, which would equal 5z. And 6 plus 6 equals 12. All right, so I can further use these two and use elimination. So I need something to match up, and I can see that this 4x, if I multiply everything by 2, I can get 8x. So I'm going to multiply by 2. So I have 8x plus 10z equals 24. Now I want these to cancel out, so I'm going to subtract. So these 8 minus 8 gives me 0x. 7 minus 10 gives me negative 3z. 18 minus 24 gives me negative 6. So I can divide. And z equals 2. Now I want to find x, so I can simply plug this z into one of my other equations. So I have 8x plus 7 times 2 equals 18. So I just plugged z in. So I get 8x plus 14 equals 18. Subtract my 14. 8x equals 4. Divide by 8. X equals 1/2. So far I have the ordered pair 1/2, I don't know, and 2. So to find my y coordinate, I can simply plug back into one of my original equations. So I'm going to do 2 times 1/2 minus 3y plus 2 times 2 equals 6. So I literally just took this equation here and I replaced the two variables I did know so I can find the last one. So 2 times 1/2 is 1 minus 3y plus 4 equals 6. Okay, I do 1 plus 4 equals 5. So I have negative 3y plus 5 equals 6. I'm going to subtract 5 on both sides. So I end up with negative 3y equals 1. Divide by negative 3. Divide by negative 3. Y equals negative 1/3. So I've got my x, my y, and my z. So the ordered pair where these intersect at is 1/2, negative 1/3, and 2. So this is my final answer.